Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be talking about alcohols. So firstly we're going to talk about what is an alcohol, so what do we mean when we use that term. We're going to look at the three types or categories of alcohols, and then we're going to look at the naming rules around how we name alcohols, so looking at some of the specific rules and then some examples to help illustrate them. So what are alcohols? Well, we've got three examples of alcohols here in the structures in front of you. We're seeing methanol, ethanol, and butan-2-ol. Alcohols are hydrocarbons that contain one or more hydroxyl or OH groups, somewhere within that structure. You can see that's a common feature to each of these structural formulae. So it's called a hydroxyl, not a hydroxide, which is the ion, which is OH minus, but hydroxyl as a substituent, a thing that's connected to something else. More formally by the IUPAC technical rules, they're known as alkanoids, but more commonly referred to as alcohols in everyday kind of contexts, in the way that people discuss it and understand it. So that's the term that we are going to use here in this video and from now on. So there's three main types of alcohols based on their structure. Now we're only focusing on ones that have one OH here at the moment because that's kind of where we kind of start. But so we define alcohols as primary, and then we will look at secondary and tertiary in a moment. So primary alcohols, so we're focusing, in order to categorize them this way, we're looking at how many carbon groups are attached to the carbon with the OH on it. Okay, so primary alcohols have one carbon attached, like this one here. This is ethanol, but I've just drawn it in this kind of semi-abbreviated way to help you to be able to see the structure around this carbon. So one carbon at one carbon group. Secondary have two carbon groups, designated here as the general kind of placeholder R ones. Like we're seeing here, we've got one carbon, two carbons attached to this OH carbon. And then logically, tertiary has three. So the carbon where the OH on it has no hydrogens attached to it directly, it's all other carbon groups of some size. Okay, like we're seeing here, this one's 2-methyl propan-2-ol. It's also, in an old-fashioned name, is tertiary butanol, just because of the fact that you've got these four carbons attached in this T shape to the OH group. So you can see this carbon here has no hydrogens attached to itself. So primary's got one carbon, secondary's two, tertiary is three. Now you notice that there's no kind of category for having zero carbons attached. Now there is one that if this was a hydrogen, this compound would be methanol. That does exist, but because it's the only one that exists, it's not necessary to have a category all on its own for one substance. And besides, the way that methanol reacts tends to, in subsequent things that we're going to look at, behaves very much like primary alcohols do. So it's kind of, in all the ways that it matter, it's much the same. Okay, so primary, secondary, and tertiary. And these are the general kind of formulas and then some specific examples. So how do we name alcohols? What specific rules do we need to remember in addition to what we're already familiar with in naming hydrocarbons? So essentially we're looking at a lot of the same properties as naming an alkane. Okay, that we're looking at an alkane structure that has an OH substituted into it. We use, because of the fact that this OH means that it is its own family, it's got specific properties, that we use a new suffix. So we put ol at the end of the name. So for most alcohols, what we're doing is we're taking the name of the alkane, we drop the E at the end, and then we replace it with ol. Okay, so I'll show you what that looks like in a moment. But one thing to keep in mind here is that only applies if there's one OH group. If there's two or more OH groups, there's two things to keep in mind. Firstly, we put di or tri directly in front of the ol part of the name. So it's diol, triol. Okay, but what we do then is that we actually keep the E at the end of the alkane name, because then we're going to put locants directly in front of that section. And you'll see what that looks like in a moment. It's just part of the convention there. It's just a little tweak depending on how many OH groups that we have. We need to use a locant for each OH group. We use it directly next to the ol suffix. Now, one thing to keep in mind here, especially if there's branches and other things like that, is the OH group takes priority in our numbering system. So we always number from the end closest to the OH group. Even if there are other possibilities that could give lower sets otherwise, that one takes the precedence. So keep that in mind. All right, so let's look at an example here. We've got this compound. It's got 3 carbons, it's got an OH group over here. So 3 carbons, so we're going to use prop as our stem. Okay, if this were an alkane, it would be propane. Okay, we've got an OH group that's on the end carbon, or carbon number 1. So it's going to have a locant of 1. So then what we do is we write, it would be propane, we drop the E, we put ol, but we put the locant of 1 directly next to the ol to show that that's where the OH group is attached. Now, it looks a little clunky in some respects. It's the same sort of process we use for alkenes and alkynes, just to try and make sure that the number is directly associated with the part of the name that it relates to. Because if the number is too separated from it, then it can get a little confusing as to where each part is. And especially if we kind of look beyond our syllabus and look at more detailed kind of ones that have multiple functional groups, then it means that then we can keep it really connected, make it as unambiguous as possible. Now let's have a look at this example. Okay, so we can see here that we've got 2 OH groups. We've got 2 carbon chains, so we're going to use eth as our stem. Okay, if this were an alkane, it would be ethane. Okay, because it's got 2 H groups, it's going to be a diol in the end part of our name. So it would be ethane. We're going to need a diol. We look at the fact that an OH group is on carbon 1 and carbon 2. Now, in this situation, obviously, we could number from either end and it would be the same. It's a symmetrical molecule. But it's important to note that they're not on the same carbon. Okay, that's the thing we're trying to illustrate. So locants of 1 and 2. So what we do is that we say it's ethane, we keep the E, we do 1, 2, and then diol. So that's showing that it's got 2 carbons. We've got an OH group on carbon number 1 and number 2 for a diol. So you can see that we don't drop that E in this situation when we did in the previous one of propan 2-ol, or propan 1-ol. So what we can see here is that alcohols are hydrocarbons that contain 1 or more OH or hydroxyl groups. That they come in 3 types depending on how many carbons are attached to the hydroxyl carbon. Do we have 1, making it primary, 2, making it secondary, and 3, making it tertiary? And looking at the naming rules of alcohols, so using the ol suffix and some of those principles, and we went through a few examples. All right, thanks very much for watching. Don't forget to like and subscribe. Bye for now.